Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the practice questions on arc length. If you need any extra help on arc length, if you go to Corbettmaths and go to the videos and worksheets section and scroll down to video number 58, there's a dedicated video tutorial there on arc length. Alternatively, you could scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, let's have a look at our first question. So first question says, a semicircle has got a diameter of 20 meters. So here we've got a semicircle and it's got a diameter of 20 meters. So we've got this diameter and then the arc. And then the question says, calculate the perimeter of the semicircle. So we want to find the distance around the outside of the semicircle. So that would be the length of the arc plus 20. And then that would be the perimeter of the semicircle. So to do that, we need to work out the length of this arc. And what we're going to do is we're going to consider the whole circle. So we're going to consider the whole circle like so. And we're going to do pi times diameter. That would give us the circumference of the whole circle. And then we would divide that by 2. And then when we do that, that would give us the length of this arc. And then we can add on 20, and that would be the perimeter of this semicircle. Okay, so to find the circumference of the whole circle, we would do circumference equals pi times diameter. So circumference equals pi times diameter. We would do pi multiplied by the diameter of the whole circle, which is 20. So, and this is a calculator question, so that's quite nice. We can do pi times 20 in our calculator, and that'd be 20 pi, or as a decimal number, 62.83185 and so on meters. So that's the circumference of the whole circle. We want to find the length of this arc, which is a half of the whole circle, so we just now need to divide by 2. So we'll take our 62.83185 and so on, or our 20 pi, and then we'll just divide by 2. And if we divide that by 2, that's equal to 10 pi, so that's equal to 10 pi, or 31.4159 and so on. So that's the length of this arc. So the length from here around to here would be 31.4159 and so on meters. So that's the distance from here around all the way around to here. So that's the length of that arc. So in terms of finding the perimeter of the semicircle, I'm just going to actually just get rid of this so we can see it a little bit more clearly. Let's get rid of this part here. If we want to find the perimeter of the semicircle, we just need to take the arc length, the 31.415 and so on. And I've still got that in my calculator display, or 10 pi. And then we're going to do plus the diameter, which is 20. And then when we add those together, that will give us the perimeter of the whole shape, which would be 51.4159 and so on meters. And let's just round that. I'm going to round that to 3 decimal places. So that'll be 51.41, and then we've got 5 nines, so that'll be 6 meters. So that's the perimeter of the semicircle, 51.416 meters to 3 decimal places, And that's it. Okay, let's have a look at another question. Okay, so question number 2. So question number 2, we've got this quarter circle, and we've been asked to calculate the perimeter of this sector. So you want to find the perimeter of this quarter circle. So to do that, we need to add up the lengths of all the sides of the quarter circle. So that'll be the 8 centimeters. That's the radius of the whole circle. The other 8 centimeters, which is also radius of the whole circle, and the length of the arc. So we need to find the distance from here going around to here, the length of that arc. And then once we find the length of that arc, we can add together that, the 8 and the 8, and that'll be the perimeter of the quarter circle. Okay, so let's find the length of that arc. So what we're going to do is we're going to consider the whole circle. So we're going to consider a whole circle, like so. And we're going to do pi times diameter to get the circumference of the whole circle. And then we'll divide it by 4. And that'll tell us the length of that arc. So let's do that. So the circumference equals pi times diameter. So the circumference of the whole circle is equal to pi times diameter. It's going to be pi multiplied by, and the diameter of the whole circle, so that's the distance the whole way across the circle, will be 16 centimeters. So times by 16. And when we do pi times 16, that's 16 pi, or as a decimal number, that would be equal to, or as a decimal number, that would be equal to 50.26548 and so on centimeters. So that's the circumference of the whole circle. Now we want to find the length of this arc, which is, well, because this is a quarter circle, this would be a quarter of the whole circumference. So we'll take our 50.26548 and so on, or our 16 pi, and we'll divide that by 4, and that'll tell us the length of that arc. So when we divide by 4, that's equal to 4 pi, or as a decimal number, 12.56637 and so on centimeters. So that's the distance from here around to here. That's 12.56637 and so on. So that's the length of that arc. Now we want to find the perimeter of the sector. So I'm just going to get rid of those extra lines for the minute, these ones here, just so I can see what we've got here. So we've got this quarter circle, and we want to find the perimeter of it. So we're going to take our lengths, our arc length, which is our 12.5663 and so on. And it's on my calculator display, so I don't need to round it, plus our 8 centimeters, plus another 8 centimeters, and that'll be the perimeter of the whole quarter circle. And that'll be equal to 28.5663 and so on centimeters. And let's just round that to 3 decimal places. That'll be 28.566 centimeters to 3 decimal places, And that's it. Okay, let's look at our next question, question number 3. Okay, so question number 3, it's a non-calculator question, so I'm going to put down the calculator, and we've got a quarter circle, and we've got this length is 6 centimeters. And part A says work out the length of the arc, so we want to find the length of the arc, so that's just this curved part here, and to give our answer in terms of pi. Okay, so if we want to find the length of the arc, what we're going to do is we're going to find the circumference of the whole circle. And because it's a non-calculator question, we're going to do that in terms of pi, and that's what we're told to do. So the circumference of the circle is equal to pi times diameter. So that's pi multiplied by the diameter of the whole circle. So the diameter of the circle would be 12 because the whole way across is 6 plus another 6 is 12 centimeters. So pi times 12. And that means the circumference of the whole circle will be 12 pi centimeters. So that's the circumference of the whole circle. But this is a quarter circle. So the length of this arc would be a quarter of the whole circumference. So if we take the 12 pi and we divide that by 4, that'll tell us the length of this arc. And 12 divided by 4 is 3. So 12 pi divided by 4 would be 3 pi, so 3 pi centimeters. So the distance from here around to here, the length of that arc would be 3 pi, so 3 pi centimeters. So the question says, work out the length of the arc, that'll be 3 pi, so 3 pi centimeters, and that's it. Okay, part B. Part B says find the perimeter of the quarter circle and to give our answer in terms of pi. So we want to find the perimeter of the whole quarter circle. So we've got the arc length is 3 pi. We've got this length is 6 centimeters, the radius. This is also the radius, that'll be 6 centimeters as well. So we just need to do 6 plus 3 pi, and that'll be our answer. So let's do that. So 6 plus 3 pi. Now 6 plus 6 is 12, so it's going to be 12 plus 3 pi. So the answer would be 12 plus 3 pi centimeters, and that's it. That's the perimeter of the quarter circle. Okay, so let's have a look at our next question. So our next question says, shown as a sector of a circle. So we've got the sector of a circle, and it's a calculator question, and we've been asked to work out the length of the arc. So we just want to find the length of this arc. We don't want to find the perimeter of the whole sector. We just want to find the length of the arc. So the distance go from here around to here, the length of that arc. So that's what we're trying to find. Now this is a calculator question, so that's quite nice. We can pick up our calculator again. And in terms of this question, there's a couple of ways we can approach it. One approach would be to find the circumference of the whole circle, like we've done in questions 1 and 2 and 3 so far. So we would do pi times, we could turn it into a whole circle. So we could turn it into a whole circle. It's a really bad whole circle, but we could turn it into a whole circle. And we could do pi times diameter, and the diameter of the whole circle would be 24 centimeters. So we could do pi times 24. And then what we could do is, because this is 60 degrees, this is a sixth of a circle, because 6 60s is 360. So you could get the whole circumference and then divide it by 6, and that'll tell you the length of that arc. That's one way you can do it. Another approach, and this is the approach that I'm going to use a lot more in this video now, is to use the formula. In terms of arc length, the arc length is equal to veta over 360 multiplied by pi multiplied by the diameter. And this formula would tell you the length of the arc. So we've got here veta over 360. Well, veta is the angle, so that's the fraction of the whole circle. And if you think about it, that's what we were doing anyway. Whenever we worked it out, it was the sixth of a circle. We said, well, 60 out of 360, if you cancel it down, would be a sixth of a circle. So this would just be the fraction of the whole circle. And then multiplied by pi times diameter, that's the circumference. So you're just in the fraction of the circumference. So that's what we've been doing anyway, but this is just a bit easier in terms of working it out. Okay, so if we want to find the length of this arc, what we're going to do is that's equal to veta, that's the size of the angle, so that's 60 degrees, over 360, multiplied by pi, multiplied by the diameter, that's the diameter of the whole circle. So if we've got this whole circle, the diameter of the whole circle would be 24, because the radius is 12 from the edge to the center of the whole circle. So from one side to the other side would be 24 centimeters. So the diameter is the distance across the whole circle. So if that's 12 centimeters, the diameter would be 24. So if we just do on our calculator, 60 over 360 times pi times 24, that'll tell us the arc length. So let's do that. And that's equal to 4 pi. So 4 pi. So the distance from here around to here, this arc length is 4 pi centimeters. Or as a decimal number, it would be equal to 12.56637 and so on. And so you could also write 12.56637 and so on. So that's it, we've found the length of that arc. The arc length is equal to 12.566 centimeters to 3 decimal places, Or if we needed to give our answer in terms of pi, we would use 4 pi. And that's it. So this formula is really useful. Veta over 360 times pi times the diameter, and that'll tell you the arc length. Okay, so let's look at our next question, question number 5. So question number 5, we've been given this sector, and we've been asked to find the perimeter of the sector. And we've been asked to give our answer to 2 decimal places. That's quite nice. It's a calculator question, and with an 82-degree angle, I'd like to think it is. So let's find the perimeter of this sector. So we've got here 6 centimeters, so this side would be 6 centimeters also. And now we just need to find the arc length. And remember, the arc length is equal to Veta over 360 times pi times diameter. So Veta, that's the size of the angle, that's 82 degrees, over 360, so that's the whole fraction of the whole circle. This is 82 360ths of a whole circle, times by pi, times by the diameter, so that's the whole way across the circle. So if we had this whole circle, the whole way across it would be 12 centimeters, so times by 12. So we just type this into our calculator now, and that's equal to 41 over 15 pi, or 8.587 and so on centimeters. So that means that the distance from here, so from here around to here, would be equal to 8.587 and so on centimeters. And that's fantastic. We've now found the arc length, and that means we can find the perimeter of the sector, because we can now just do 6 plus 6 plus the arc length, which is 8.587 and so on. So let's do that. So 8.587 and so on plus 6 would be the perimeter of that sector. And when we do that, we get an answer of 20.587 and so on centimeters. And the question says to give our answer to 2 decimal places, so that'll be equal to 20.5, and then we've got 87, so we're going to round up, so it'll be 9 centimeters to 2 decimal places. And that's it, we've found the perimeter of that sector. So question number 6 is a non-calculator question, so reluctantly I'm putting down my calculator. And we've been asked to find the length of the arc, so we want to find the length of this arc. We don't need to find the perimeter of the whole sector, just this arc. And we've been asked to give our answer in terms of pi. So what I'm going to do here is I'm going to use the same formula as before. So remember, the formula is Veta over 360 multiplied by pi multiplied by the diameter. So that'll give us the arc length. So Veta, that's the size of the angle, which is 40 degrees, over 360, multiplied by pi multiplied by the diameter of the whole circle. So if we had a whole circle, the diameter of the whole circle would be 36, because we've got 18 plus another 18 would be 36, so multiplied by 36. That's the diameter of the whole circle. Okay, now let's cancel down this fraction. We've got 40 over 360, so 40 over 360. If we divide both of those by 10, we get 4 over 36. And then if we divide both of those by 4, we get that's equal to 1/9. So this is a ninth of a circle. So what we've got is we've got a ninth multiplied by pi multiplied by 36. Now here, what I'm going to do is I'm going to do a ninth of 36, because a ninth of 36 is the same as a ninth times 36. So a ninth of 36 is equal to 4, so that would be 4 pi. So the answer would just be 4 pi. So that means that the arc length, the distance from here around to here, in terms of pi, would be 4 pi. So 4 pi centimeters. And that's it. That's the length of that arc. So the answer is 4 pi. And that's it. Okay, let's look at our next question. Okay, let's have a look at our next question, question number 7. So question number 7, we've got this sector. It's quite a large sector, and we've got an angle of 285 degrees, and we've been asked to find the perimeter of the sector. So the perimeter of the sector is the distance around the outside. So we've got our 4 centimeters, our other 4 centimeters here, and then we've got the length of the arc. So we need to find the length of the arc. So remember, the arc length is Veta over 360 multiplied by pi multiplied by the diameter of the whole circle. So the whole circle, the diameter would be 8, so times by 8. So then we've got Veta, that's going to be 285, so 285 over 360, that's the fraction of the whole circle, times by pi times by 8. And on our calculator, let's type that in and see what we get. And that would be equal to 19.8967 and so on. And that means the distance from here around to here, so this arc length going from here all the way around to here, the arc length would be equal to 19.8967 and so on centimeters. So that's that arc length. We want to find the perimeter of the whole sector, so we're going to take the arc length, the 19.8967 and so on, and we're going to add 4 and another 4. So add 4 add 4. And when we do that, we get an answer of 27.8967 and so on. And let's just round that. Let's round it to one decimal place. So to one decimal place, that'll be 27.9 centimetres to one decimal place, to 1 dp. And that's it. That's the perimeter of that sector, 27.9 centimetres to one decimal place. Okay, let's look at our next question, question number 8. Okay, so question number 8, we've got that AOB is a sector of a circle. So AOB, so we've got AOB here, is a sector of a circle with centre O and radius 1.8 metres. And we've got this angle here outside of the sector is 120 degrees. And we've been asked to find the perimeter of the sector AOB. Okay, so if we want to find the perimeter of this sector, the first thing I want to do is I want to work out the size of the angle inside the sector. So remember the two angles at a point here, this angle and this angle, will add together to be 360 degrees. So if we take 360 and take away the 120, that's equal to 240 degrees. So that means that this angle here is 240 degrees. The angle inside the sector is 240 degrees. So we want to find the perimeter of this sector. So we know this length is 1.8 meters. We know this length here would also be 1.8 meters because if that's the center of the circle, these are both radii. And then we want to find the arc length. So that's veta over 360 multiplied by pi multiplied by the diameter. So veta, that's 240 over 360 multiplied by pi multiplied by the diameter. So the diameter of the whole circle would be 3.6 because if 1.8 is the radius, 3.6 would be the diameter, so 3.6. So let's work this out. We've got a calculator, so let's type that in. And when we work that out, we get that's equal to 12/5 pi, or as a decimal number, 7.53982, and so on. So that's the distance from here around, all the way around, sorry, excuse my diagram there, to there. So that's the arc length from here around to here. So that's equal to 7.539 and so on meters. Now we want to find the perimeter of the sector, so we now need to work out the distance around the outside. So it's going to be 7.539 and so on, plus 1.8 plus 1.8, and that'll be the perimeter of the sector. So if we add 1.8 and 1.8 in our calculator, that gives us an answer of 11.13982 and so on meters. And let's just round that. Let's round it to two decimal places. That'll be 11.14 meters to two decimal places, to two decimal places. And that's it. So that's the perimeter of that sector, 11.14 meters to two decimal places. Okay, let's look at our next question, question number 9. Okay, so question number 9, we've got this sector, and actually here we're told that Max is calculating the perimeter of the sector, so he's calculating the perimeter of that sector. And it's a calculator question, and we've got his method there, and the question says to explain his mistake. So what I'm going to do is, before I look at his method, I'm just going to think how I would work it out. So if I wanted to find the perimeter of this sector, I would do veta over 360, so 20 over 360, multiplied by pi, multiplied by the diameter, which is 14. That would give me the length of the arc. Then I would add on the length of the two radii, so I'd add on 7 centimeters and 7 centimeters, and then that would be the perimeter of that sector. So I'd find the length of the arc and add on 7 and add on 7. So let's have a look at his method. So he's done veta over 360, 20 over 360, I agree with that, multiplied by pi, multiplied by the diameter, so the diameter of the whole circle would be 14, I agree with that. He's found the length of the arc to be 2.44 and so on centimeters, so he's found that distance here of 2.44 and so on centimeters, okay. And that's it. He hasn't added, it says calculate the perimeter of the sector. He hasn't actually calculated the perimeter of the sector. He's just found the length of the arc. He needs to add on another 7 and another 7 centimeters. And then that would be the perimeter of the sector. So he hasn't added on the length of the two radii. He's just worked out the length of the arc. So let's explain that. Okay, and I've just explained that Max has only calculated the length of the arc length, and he needs to add on the lengths of the two radii. So the two 7 centimeters, he needs to add on 7 and another 7, or adds on 14, something like that, just to calculate the perimeter of the whole sector. And that's it. Okay, let's look at our next question. So that's question number 9. Let's look at question number 10. Okay, so question number 10. So question number 10, we've been given a sector, and we've got the sector. Now this time we haven't been given the angle, we've been given the angle veta there, and we're told that the arc length is 4.4 centimeters. So the arc length, the distance from here around to here, is 4.4 centimeters. And the question says to calculate the size of the angle. We want to find the size of that angle. Okay, so let's use the arc length formula. Remember the arc length is equal to veta over 360 multiplied by pi multiplied by the diameter. So here, arc length, that's 4.4 centimeters. So 4.4 is equal to veta, that's veta, what we're trying to find the angle, over 360, so over 360, multiplied by pi multiplied by the diameter. So that's the diameter of the whole circle, which would be 12 centimeters, so times by 12. Okay, so we've now got this. We now need to solve this equation to find out what veta is. Okay, so we can do this in lots of different ways. We could divide both sides by pi. We could divide both sides then by 12, and then we can multiply both sides by 360. We could do 12 times pi first of all, get that number, and then divide both sides by that answer, and then times by 360 and so on. But it doesn't really matter. As long as you follow the steps in terms of solving an equation, you'll find the size of this angle here, this veta. Okay, so what I'm going to do is I'm going to divide both sides by pi to begin with. So I'm going to divide by pi, and I'm going to divide by pi. So on the left-hand side, I've got 4.4, and I'm dividing that by pi, and that's equal to 1.40056, and so on. And then on the right-hand side, we had veta over 360, so we've still got that. We divided by pi to get rid of the times by pi, so then we've still got our times 12. Now I'm going to divide both sides by 12, so I'm going to divide by 12 and divide by 12. So on the left-hand side, I'll divide by 12, and I get an answer of 0.11671, and so on. And then on the right-hand side, I've got veta over 360. Okay, I'm just going to write this out here again. So I've got 0.1167 and so on equals veta over 360. That's where I've got to there. And then I want to find out what veta is. So I don't want this to divide by 360. So I'm going to times by 360 and times by 360. And on the right-hand side, I'll just be left with veta. On the right-hand side, if I times by 360, that gives me an answer of 42.0169 and so on degrees. So let's round that to 3 decimal places. So to 3 decimal places, veta would be equal to 42.017 degrees to 3 decimal places. And that's it. That's the size of that angle. Okay, let's look at our next question, question number 11. So question number 11, we've got the sector, and again, we don't know the size of the angle, it's just been labelled veta. And we've got the length of the radius is 14 centimetres, and we're told the perimeter of the sector, so the perimeter of the sector this time, is 57.32 centimetres. And we've been asked to find the size of the angle. So this time, we haven't just been told the arc length, we've been told the perimeter. So remember, the perimeter of the sector, it has the sides consist of the radius, and the arc length. Well, the radius is 14 centimetres, that means that this radius is 14 centimetres. And if we take those two 14s away from 57.32, we can then find the arc length. So let's do that. So 14 plus 14 is equal to 28. And then if we have our 57.32 and take away 28, that's equal to 29.32. So that means the arc length, the distance from here around all the way around to here, will be equal to 29.32 centimetres. And we can check that if we do 14 plus the arc length, we get our 57.32. Okay, now we've been asked to find the size of the angle. So we're going to use our formula that the arc length, which is 29.32, is equal to veta over 360 multiplied by pi multiplied by the diameter. And the diameter of the whole circle is 28, so multiply by 28. Okay, so that means we've now got our equation and we want to solve it to find veta. So I'm going to divide both sides by pi to begin with, so divide by pi and divide by pi. You could divide by both sides by 28 if you wanted to, or you can actually work this out and then divide both sides by that and so on. But I'm just going to take the 29.32 and divide that by pi. And I get that's equal to 9.3328 and so on. And I'm going to keep that, I'm not going to round it. And that's equal to, on the right hand side, we had veta over 360. We divided by pi to get rid of the times by pi, so we're just left with multiply by 28. Now we want to get the veta on its own, so let's get rid of this 28. So let's divide by 28 and divide by 28. So we're going to divide by 28, and that gives us an answer of 0.33331599237 on the left hand side. And on the right hand side, we had veta over 360 times 28. We divided by 28 to get rid of the multiply by 28, so we're just going to be left with veta over 360. Okay, and then finally, we want to get rid of this divide by 360, so we're going to times by 360 and times by 360. So on the left hand side, if we just times by 360, that gives us an answer of 119.9937 and so on degrees. And the right hand side would just be left with veta. And that's it. So we're asked to calculate the size of that angle, so it's 119.9937 and so on degrees. Or you could round it, the two decimal places to be 119.99, so 119.99 degrees. Or you could even round it to the nearest degree to be 120 degrees and so on. So that's the size of that angle, 119.99 degrees to two decimal places. And that's it. Okay, let's look at our next question. Okay, let's have a look at our next question, question number 12. So question number 12 says, Mariam's garden is a sector OAB. So OAB, that's a garden, and it's a sector. And there's a fence going around the outside of the garden. So there's a fence going around the outside of the garden. She paints the straight sections of the fence OA, so OA and OB, they're straight sections of the fence, so the radii of the sector, that's a radius and that's a radius, blue. And she paints the curved section of the fence, this curved section of the fence, the arc AB, green, so she paints that length green. And then the question says, work out the percentage of the fence is painted green. So we want to find the percentage of this whole fence is painted green. So what we need to do there is we really need to work out the perimeter of the whole sector. That'll tell us the length of the whole fence. And then we need to work out how much of it is green. That'll be the arc length. And we'll have worked that out. If we worked out the perimeter of the whole sector, we'll have worked out the arc length. And we'll work that length out to be the arc length. And then we'll just write that as a fraction, the arc length out of the whole fence, the whole perimeter. And then just convert that into a percentage. So let's do that. So let's find the arc length to begin with. So the arc length, so that's going to be β over 360 times by pi times by the diameter of the whole circle. And that'll be the arc length. So β, that's going to be 80 degrees. So 80 over 360 multiplied by pi, multiplied by the diameter of the whole circle. And the diameter of the whole circle would be 18 meters. So 18 meters. Okay, so we've got β over 360 times pi times 18. Now let's work this out. So on our calculator, we'll type that in. And that's equal to 12.56637 and so on, or 4 pi. I'm just going to write 4 pi for the moment. So that's equal to 4 pi. That length is 4 pi, or as a decimal number, 12.566 and so on meters. So we've now found the length of the arc. The length of the arc is 12.566 and so on meters, or 4 pi meters. That's the length of the arc. We now want to find what percentage of this fence is painted green. So let's find the perimeter of the whole thing. So I'm just going to write down the length of the entire fence. So in terms of the length of the entire fence, that would be the perimeter of the sector, because obviously we've got the straight bit, and the curved bit. That's the whole fence there. And then, so the perimeter would be the arc length, our 12.566 and so on, plus the radius and the radius, so plus 9 and plus 9. And that would be equal to 30.56637 and so on meters. So we've found the length of the whole fence. Now the question says, what percentage of the whole fence is painted green? So in other words, we've got this bit's green, the 12.5666 and so on, out of the 30.566 and so on. So let's write that as a fraction to begin with. So as a fraction, that'll be 12.566 and so on. That's the length of the green part of the fence, over the length of the entire fence. That's going to be 30.566 and so on. And then we just need to write that as a percentage. So let's write it as a decimal to begin with. So let's divide our 4 pi, or our 12.566 and so on, by our answer. And that's equal to 0.4111175,243. So that's that expressed as a decimal, and let's times by 100 to get it as a percentage. If we then times by 100 and then multiply that by 100, gives us an answer of 41.11175243 and so on %. And that's it. And the question says to give our answer to 2 decimal places, so we need to round this to 2 decimal places. So that'll be 41.11% to 2 decimal places, to 2 decimal places. And that's it. So we found the percentage of this fence that is green. So we found the length of the whole fence, that's the perimeter of the whole sector. We found the arc length, and then we just wrote that as a fraction, the arc length out of the whole fence, the whole perimeter, and then just converted that to a percentage. And that's it. Okay, let's have a look at our next question, question number 13. So question number 13, we've got this diagram, we've got the center of the circle here, and we have got that this length is x, and we've got that this angle here is 36 degrees, and we're told that the major arc length is 31.1 centimeters. So the major arc length, so we've got the minor arc length here, and the major one going around the outside. So I'm going to try and draw this. It probably won't be the tidiest, but if I go around the outside here, this major arc length, not done too badly so far. It's quite hard here. So from there to there, that would be 31.1 centimeters, the major arc length. We want to find the radius of the circle, this length here, labeled x. Okay, so we've been told the major arc length is 31.1 centimeters. What I'm going to do now is I'm going to find the size of this angle here, because these two angles will add together to be 360. So if I do 360, take away 36, that's equal to 324 degrees. So that means the size of this angle here is 324 degrees. And here we've now got the size of the angle, the β, we've got the arc length, and we just want to find here the radius, the length here we labeled x. So let's write down the formula. The arc length is equal to veta over 360 times pi times by the diameter. So the arc length, that's 31.1, is equal to veta, that is our 324 over 360, multiplied by pi, multiplied by the diameter. So what we can do is we can use this arc length formula to find the diameter of the whole circle, because we can find here d. And then once we find that, we can half it to find the radius of the circle. So let's do that. So we want to solve this equation to find d. Okay, so to solve this equation, well, we want to get the d on its own, so we don't want to multiply by this fraction here, so let's divide both sides by 324 over 360. So divide by 324 over 360. So if I take 31.1 and I divide it by 324 over 360, that's equal to 311 over 9, or as a decimal number, 34.555555, and so on. And that's equal to, now we divided by that fraction to get rid of it, so we're just left with pi times diameter, pi times diameter. You could have written that as a decimal number as 34.555 if you wanted to. Okay, now we don't want this pi here, so we're now going to divide both sides by pi. So let's divide by pi and divide by pi. So we're just going to divide by pi, and that gives us an answer of 10.999379496, and that's equal to, and we divided by pi to get rid of the times by pi, so we're just left with the diameter. So we've now found the diameter of the circle. We want to find the radius of the circle, so we now just need to half this. So we now just need to divide by 2, and if we take that number and we divide it by 2, so just divide by 2 on our calculator, we get the x, the radius, is equal to 5.4999687, and so on, centimeters. And I'm going to round this, I'm going to round it to one decimal place, so that'll be 5.5. So it's 5.5 centimeters to one decimal place, and that's it. So we found x, the radius of that circle, and that's it. Okay, let's have a look at our next question, question number 14. So question number 14, we've got the sector, and we're told the perimeter of the sector is 1 meter. And we've been asked to find the length y, the radius of the circle. So we want to find this length here, y, the radius of the circle. So it's actually quite similar to the last question, apart from last time. If we look back at our last question, we were told the arc length. This time we've been told the perimeter of the circle rather than the arc length. Okay, so we want to find this distance here, y, this length here, the radius of the circle. So the first thing I'm going to do is I'm actually going to work at the sides of this angle here inside the sector. So I'm going to do 360, take away 130, and that's equal to 230 degrees. So we found the sides of that angle, 230 degrees. Now we want to find this distance here, the radius of the circle, y. So well, we know if that's y, this side here would be y as well. Okay, so we've now found the size of this angle is 230 degrees, and we've got the length of the radius is y and the length of the other radius is y. And we want to find the length of that radius, so we know the perimeter of the whole sector is 1 meter. Now I'm going to change that 1 meter because it's the whole perimeter, and we're trying to find the length of the radius, which should be smaller than the perimeter of the whole sector. So what I'm going to do is I'm going to change this into 100 centimeters, just so whenever we're dealing with it, we're looking at it in terms of centimeters. You could leave it as 1 meter if you wanted to. So if we wanted to find the perimeter of this whole sector, what we would do is we would use our arc length formula, 230 over 360, multiplied by pi, multiplied by the diameter of the whole circle. Now if the radius of the circle is y, the diameter of the whole circle would be 2y, so 2y. So that's the arc length. But then for the perimeter of the whole circle, we would then add on a y and add on another y. So we would add on y and add on y. And then that would be equal to the perimeter of the whole circle, which is 1 meter, or I'm going to use 100 centimeters. So here we've got the perimeter of the whole sector. We've got veta over 360 times pi times the diameter, the arc length, plus the 2 radii is equal to the perimeter. So that's our equation. And now what we're going to do is we're going to solve this equation. So I'm going to do this part in our calculator. So we've got 230 over 360 times pi. So 230 over 360 times pi. And that would be equal to 2.00712 and so on. Multiplied by 2y plus y is equal to 100. Just working out this part. Now I'm going to do the multiplication, remember our order of operations. So if I was to do 2.00712 and so on times 2y, well I could just times this 2.007 so on by 2 and then put the y on the end, so times 2, and that would be equal to 4.014 and so on, y, just timesing those together. And then we're still adding y, and that's equal to 100. Now here we've got 4 point something y, add another y, add another y. So we're adding on 2 y's onto this. So that would make this 6.014 and so on y. Because we had 4 point so on lots of y and another lot of y and another lot of y. So that'll be plus 2. That's equal to 6.0142572 and so on y. And that's equal to 100. And then finally, if we wanted to find the length of y here, we just need to divide both sides of this equation by this 6 point so on. So divide by 6.014 and so on, divide by 6.014 and so on. So on the left hand side, we'd just be left with y. On the right hand side, if we do 100 divided by this 6 point so on, we get that's equal to 16.627 and so on. So that means that the length here of y, do we need to give it any number of decimal places? No. That means that y is equal to 16.63 centimeters to 2 decimal places. And that's it. Okay, so let's have a look at our next question, question number 15. So question number 15 says, Holly's designed a garden which consists of a patio and a grass lawn. So we've got the patio here in white and the grass lawn here in green. And that's what this tells us, that the garden CEF, this whole garden, is a sector of a circle, center C. So this is a sector of a circle, center C. The patio, CDG, that's the patio there, is also a sector of a circle, center C. And the shaded region DEFG is the grass lawn. So this is the grass lawn. And we're told the angle ECF is 40 degrees, so angle ECF, so that's the angle here, is 40 degrees. So that's fantastic. We know the sides of that angle, and that'd be quite useful for us in the rest of the question. And then the question says to calculate the perimeter of the grass lawn, the shaded region. So we want to find the perimeter of the shaded region here. We want to find the perimeter of this green region here. So in terms of the perimeter of this green region, well, it's got 4 sides. It's got 2 straight sides and 2 curved sides. So in terms of the straight sides, so ED or DE, the whole length here is 10 meters. And this part is 2 meters, and 10 take away 2 is equal to 8. So that means that ED is equal to 8 meters. And likewise, FG or GF is also equal to 8 meters because the whole side here is equal to 10, and that's 2, that's equal to 8. So that's straightforward. Now we want to find the lengths of the 2 arcs. We want to find the length of the arc DG, and we want to find the length of the arc EF. So let's start off with DG. So in terms of DG, the arc length, well, beta over 360 multiplied by pi multiplied by the diameter will give us the arc length. So beta, that's the angle, which is 40 degrees, over 360 multiplied by pi multiplied by the diameter of the whole circle. So if we look at this little circle here, we're trying to find the length of that arc. The radius is 2 meters, so the diameter of the whole circle would be 4 meters, so times by 4. So we just need to work this out. So let's do that. And when we work that out, we get an answer of 4/9 pi. So that means that this arc length here is 4/9 pi meters. So that's 4/9 pi, the distance from here to here. Or if you have it as a decimal number, 1.396 and so on meters. I'm just going to leave it in terms of pi for the moment because we're going to be adding them all up at the end anyway to find the perimeter of the whole grass lawn. Now we need to find the length of this arc length here, EF. So again, we're going to use beta over 360 times pi times the diameter. So beta, that's the size of the angle of the sectors, that's 40 degrees, so 40 over 360 multiplied by pi multiplied by the diameter. So if this is the center of the circle, that would be quite a big circle, and if the radius is 10, the diameter of the whole circle would be 20, so times by 20. So let's work this out and see what we get. That's actually quite nice. I can just delete the 4 on my calculator and type in 20, and I get an answer of 20 over 9 pi meters. So the distance from here to here would be 20 over 9 pi meters. So that's the distance from here to here. We've got the distance from here to here, and that distance and that distance. Or if you wrote this one as a decimal, by the way, it'd be 6.9813 and so on meters. Okay, now we've been asked to find the perimeter of the grass lawn. So we now just need to add up the lengths of the 4 sides. So let's do that. So it's going to be 8 plus 8 plus 4/9 pi plus 20/9 pi. And then that would be the perimeter of the grass lawn. So let's work that out. And that's equal to 24.3778 and so on meters. And let's just round that. Let's round the 2 decimal places. That'll be 24.3 and then we've got 77, so that'll be 8 meters to 2 decimal places. And that's it. We've found the perimeter of that grass lawn, the shaded region. And we've done that by finding the lengths of the 2 straight sides, by doing 8 take away 2 to find those lengths. And then we found the arc lengths by using β over 360 times pi times the diameter. And β for both of them were 40 degrees because they've both got a 40-degree angle, both sectors have got a 40-degree angle. And for this one, the diameter of the whole circle was 4, and the diameter of the whole circle for that one was 20. And we just worked out those arc lengths and then added them all up. And we got our perimeter of that shaded region to be 24.38 meters to 2 decimal places. And that's it. So in this video, we've looked at the video solutions to the practice questions on arc length. I really hope you found this video useful. If you need any extra help on arc length, if you go to Corbettmaths and go down to the videos and worksheets section, there's a video tutorial there on arc length and it's video number 58. Alternatively, you could scan this QR code. But I really hope you found this video useful. If you have found it useful, please like it and please subscribe to my YouTube channel. Thank you. Cheers. Bye.